Good morning. Today we can start fifth unit, microcontrollers. Okay, so that is the fifth unit. In this module, we will be studying a microcontroller 8051 microcontroller and its architecture and the instruction set and different some simple programs and all. Okay, so microcontrollers. First, we can study what is a microcontroller. Okay, then where we are using these microcontrollers? What are the that means what are the different applications of microcontrollers? And uh, after that we can start our 8051 microcontroller. Okay, so microcontroller. I think all of you know. Some of you already studied this subject in minor and all. Okay, so microcontroller means we can say it is a small computer. It is a small computer. We can say like that, but it is a chip. Okay, and so we can say microcontroller is a small computer on an single IC chip. Okay, small computer means what is a computer? Computer has CPU will be the RAM, ROM, input connections, buses will be everything will be there. Okay, so that is why we will call microcontroller as a single or a small computer. Okay. Generally, we can say microcontroller means it is a small computer on a single metal oxide semiconductor integrated circuit or IC chip. Okay. A small computer on an IC chip. That is what we will call it as a microcontroller. Okay. So a microcontroller will contain, it has CPU will be the, that means central processing unit will be the, RAM will be the, ROM will be the, ROM or EEPROM, depending upon the different variants of microcontroller. Different types of my different variants are there. In this 8051 itself has different variants are there. Okay, so depending upon the variants, different RAM or EEPROM, and the size of the RAM may be vary depending upon the different versions. Okay, so it is having CPU will be the RAM. Actually, RAM it is used for storing the data. Okay, generally we will call RAM as a data memory, and the ROM or EEPROM these will be used for storing the codes. Okay, so RAM will be the ROM or EEPROM will be the then input output ports are the for connecting the input and output devices for data transmission. Okay, so that is input output ports will be the timers and counters are the for timing and counting operations. Serial ports are the for connecting serial devices to the microcontroller. Interrupts will be the buses, that means data bus, address bus, bus in that data bus, address bus, control bus, everything is there. Okay. So that is why we will call it is microcontroller means it's a simple computer, small computer, right? A single computer, small computer in a ICT. Everything, whatever the things in the C computer, everything will be in the microcontroller, but all these will be in a single IC. So that is what the microcontroller. Okay, it has processor that is what the CPU, RAM, ROM, or output port, serial timer or counter. Serial ports are the interrupts are the single. for performing particular application. He can use for any other purpose computing operations. Okay, so that is what the microprocessor. It finds its use in general purpose computing. But in microcontroller, these are manufactured only for a specific application. Okay, microcontrollers are manufactured only for a specific application, like uh, a particular microcontroller may be designed for washing machine. You may see one microcontroller will be there in AC, okay, AC, or for particular or each specific application, the microcontroller will be designed. Okay, that means microcontrollers are designed only for a specific application. Okay, so that is the first difference. Find its use in general purpose computing system in case of microprocessor. But in case of microcontroller, it is used in systems that are manufactured for specific applications. Okay. Microprocessor, suppose if you want to add a different
Sir, സൗണ്ടില്ല.
okay, so we can say microcontroller കിട്ടുന്നുണ്ടോ? കേൾക്കുന്നുണ്ടോ?
സർ ഇപ്പോൾ കേൾക്കുന്നത് കട്ടായി പോകുന്നുണ്ട്. കട്ടാവുന്നുണ്ട്.
കട്ടായി പോകുന്നുണ്ട് അല്ലേ? ഇപ്പൊ ക്ലിയർ ആണോ? ഓക്കെ
ഓക്കെ.
ഓക്കെ ആണല്ലേ. സോ നമ്മൾ ഡിഫറൻസ് ആയിരുന്നു പറഞ്ഞു കൊടുക്കുന്നത് അല്ലേ? That means micro processor and microcontroller. So microcontroller means processor with additional RAM, ROM, serial port, parallel interface, timers, interrupt, everything within a single computer. But in processor, it contains only the processor. Then if you want to add additional memory on it, you need to add it additionally. Okay, so that is a second difference, microprocessor and microcontroller. Then next difference is that in microprocessor, it has large number of data transfer instructions are there. Okay, because it is useful for general purpose. Okay, so it has large number of data transfer instructions are there, but comparatively this microprocessor controllers comparatively less such instructions. Okay, and also in microprocessor, size of PCB is very large. We have seen our system computer, everything is very large, but in microcontroller, size of PCB is small compared to the processor. And also in case of power consumption, for a processor, it requires more power compared to this microcontroller. It will have comparatively less power utilization, power consumption. Okay, so these are the differences. കുറച്ച് ഡിഫറൻസ് ആണ്, കുറെ ഉണ്ടാവും, നിങ്ങൾക്ക് കണ്ടുപിടിക്കാം. ഓക്കെ, മെയിൻ ഡിഫറൻസസ് ബിറ്റ്വീൻ ദിസ് പ്രോസസർ ആൻഡ് കൺട്രോളർ, മൈക്രോ പ്രോസസർ ആൻഡ് കൺട്രോളർ. ഓർത്ത് വെക്കേണ്ട പോയിന്റ്സ് ഇത്രയാണ്. മൈക്രോ കൺട്രോളർ ഈസ് എ processor with additional memory, serial port, everything within a single chip. All these components are with the single chip. That is called the controller. Okay. So processor means we already studied. Processor processor മാത്രമേ. What are the things that require? If you want to add, you need to add additionally. If you want to add a ROM, you need to add addition. Everything you need have to add additionally. But in controller, everything will be built in that single chip. Okay, so that is what the microcontroller. Microprocessor find its use in general purpose computing system. Microcontroller used for a specific application. Okay, these are manufactured for a specific application. And microprocessor that do not contain these I/O ports, timers, memories, and anything. But microcontroller, everything will be the RAM, will be the ROM, serial port, everything will be the timers, interrupt circuit, in a single chip. Okay, and also it has microprocessor has large number of data transfer instruction. Compared to microprocessor, microcontroller has less number of such instruction. And size of the PCB will be very large in microprocessor. Compared to microprocessor, size of the PCB is small. Okay. Then power consumption also microprocessor power consumption high, and microcontroller it is compared to this it is low. Okay. So these are the differences. Okay, these are the difference between microprocessor and controller. Sometimes 3 marks question ചോദിക്കാം. Okay, ഓർത്ത് വെക്കുക difference. So these are some of the applications of microcontroller. In your cell phone, it is using microcontrollers are using pager, watch, calculator, video games, alarm. Wherever it is, air conditions, washing machine, TV remote, microwave oven. Okay, electronic smart weight, everything. Now microprocessor അതായത് embedded systems യൂസ് ചെയ്തിട്ടുള്ള വർക്ക് ചെയ്യുന്ന എവറിത്തിങ് എന്താണ് മൈക്രോകൺട്രോളേഴ്സ് ആണ് അധികം യൂസ് ചെയ്യുന്നത്. ഓക്കെ, സെൽ ഫോണുണ്ട്, പേജസ്, വാച്ച്, കാൽക്കുലേറ്റർ, വീഡിയോ ഗെയിംസ്. ഓക്കെ, സോ ദീസ് ആർ സം ഓഫ് ദ ആപ്ലിക്കേഷൻസ്. നിങ്ങൾക്ക് വേണമെങ്കിൽ കണ്ടുപിടിക്കാം. പറയാം, എവിടെയും നമ്മളിപ്പോൾ നോക്കിയാൽ മൈക്രോ കൺട്രോളേഴ്സിന്റെ ആപ്ലിക്കേഷൻ ഇല്ലാത്ത ഫീൽഡ് ഇല്ല അല്ലേ? ഓക്കെ, നൗ we can start our 8051 microcontroller. Okay, 8051 microcontroller. 8051. Actually, it is designed by Intel. Okay, Intel in 1981. Okay, it is designed by Intel in 1981, and we will call it is an 8-bit microcontroller. Okay, 8051 is an 8-bit microcontroller, and also it is built with 40-pin DIP. What is DIP? There is no DIP. 40-pin DIP. What is DIP? Anybody? What is DIP?
Dual
40-pin
inline
DIP
pin.
means dual inline package. That means the pins are arranged in either side of the IC. Correct. Okay. അതായത് പിന്ന് 40 പിൻസ് ഉണ്ടാവും. സോ ഈ 40 പിൻസ് എന്ത് ചെയ്യും? IC-യുടെ രണ്ട് സൈഡിലായിട്ട് ദാറ്റ് വിൽ ബി അറേഞ്ച്ഡ്. ഓക്കെ, സോ 8051 microcontroller, so designed by Intel in 1981. It is an 8-bit microcontroller, and it is having 40 pins. Okay, it is having 40 pins. Pins are arranged in DIP manner. That means dual inline package. That means all the pins are arranged in either side of the IC. Okay. Now we can see the features of this 8051. Now we are going to study the 8051 microcontroller. Okay, we know that it is designed by Intel. Intel നമുക്ക് എല്ലാവർക്കും അറിയാം അല്ലേ? Then Intel ആണ് ഡിസൈൻ ചെയ്തിരിക്കുന്നത്. So these are the features. First one is it is having 4 kilobytes of on-chip program memory. Okay, that may be ROM or EEPROM. Okay, so it is having 4 kilobytes of on-chip program memory. Program memory will be the it is having program memory will be the 4 kilobytes of program memory is there. We can store our programs or instruction. That will be added to this program memory. Additionally, if you want additional program memory, you can also include that also. External program memories also you can include. നിങ്ങൾക്ക് വേണമെങ്കിൽ അഡീഷണൽ ആയിട്ട് വേണമെങ്കിൽ ആഡ് ചെയ്യാം. ബട്ട് ഇൻബിൽട്ട് ആയിട്ട് തന്നെ എന്തുണ്ട്? ഇറ്റ് ഈസ് ഹാവിംഗ് 4 KB പ്രോഗ്രാം മെമ്മറി, റാം ഓർ ഇപ്രോം. ബിൽറ്റ് ഇൻ ആയിട്ട് തന്നെ ചിപ്പിൽ തന്നെ എന്തുണ്ട്? 4 KB റാം ഉണ്ട്. ഓക്കെ. ആൻഡ് ഓൾസോ 128 bytes ഓഫ് ഡാറ്റ മെമ്മറി. Okay, 128 bytes of data memory. Data memory we will call it as RAM memory. Okay, 128 bytes of RAM memory is there. 4 KB ROM memory is there. Okay, 128 byte RAM. That means our data will be stored in this RAM memory. Okay, this is on chip. ആ ചിപ്പിൽ തന്നെയുള്ളതാണ്. Okay, 128 byte RAM memory is there. And also it is having 8-bit data bus. That means 8 lines are there for transferring the data. Okay, so that is the reason why it is an 8-bit controller. Okay, so it is having 8-bit data bus. Okay, 8-bit data bus. 8-bit data bus will be there, and also 16-bit address bus is there. Okay, 16-bit address, 8-bit data bus and a 16-bit address bus. And also it is having 32 general purpose registers. Okay, 8051 having 32 general purpose register. Each register is having the size of 8 bits. Okay, each register is having the size of 8 bit. Okay, so 16-bit address bus is the 32 general purpose registers are there. Each register is having 8-bit size. Okay, and it is having two 16-bit timers. Actually, timers are used to generate the time delay and all. Okay, our processor time delay to generate timing operations we are using these timers, and also counting purposes. So timers or counter, we will call it like that. Timers or counters. Okay, actually in 8051 microcontroller, it have two 16-bit timer. We will call it as T0 and T1. Okay, T0 and T1. These are the two 16-bit timer or counter. അങ്ങനെയും പറയും, timer or counter. It can perform both timing and counting operations. Okay, so two 16-bit timers or counters are there, and also 5 interrupts are there. 5 interrupts. Okay, 3 internal interrupts and 2 external interrupts. What is an interrupt and all you already studied. Okay, so here in 8051 IC, it is having 5 interrupt signals are there. 3 internal interrupts and 2 external interrupts. Okay, 3 internal interrupts and 2 external interrupts are also there. Okay, and also 4 parallel ports are there for connecting the external device. Okay, 4 8-bit ports are there. Okay, 4 8-bit parallel ports are there. Okay, that means port 0, we will represent it as port 0, port 1, port 2, and port 3. Okay, so these all ports are 8-bit size ports. Port 0 is having the size 8-bit. Port 1 is also having the size 8-bit. Port 2 also having the size 8-bit. Port 3 also. So total 32 lines are there for IO of 8-bit 4 ports. So total 32 lines are there for performing this IO operation. Okay, performing IO operation. Total 32 lines are there for performing 32 IO lines. Okay, 32 IO lines are there for performing this IO operation, input-output operation. Okay, and also it is having 16-bit program counter. Okay, and 116-bit data pointer. We will call it as DPTR. Okay, data pointer. What is program counter? What do you mean by program counter? What is program counter? Anybody? What do you mean by program counter? Where we are using program counter? You already studied microprocessor. Here also we are using program counter. What is program counter? What is the use?
നെക്സ്റ്റ് ഇൻസ്ട്രക്ഷൻ്റെ അഡ്രസ്സ് സ്റ്റോർ ചെയ്യുന്നില്ല.
Okay, it will be point to the next address of the next instruction. Correct. Okay, it will be point to the address of the next instruction. So it is having 16-bit program counter is there. But here our processor is 8-bit. So two 8-bit registers are used for making this 16-bit program counter. Okay, so it is having 16-bit program and also 16-bit data pointer is there. We can see what is data pointer. The name itself, you can understand that it is pointing some data. Okay, that means whenever you are connecting some external memory, okay, whenever you are connecting some external memory to the controller, then for fetching the data from the external memory to the controller, okay, in that case, to point that data, we will use data pointer. Okay, so for accessing the data when an external memory is connected. Okay, so in that case, we will use data pointer to point the external memory data. Okay, so that is why we will call it as data pointer. Okay, so to point the data that is accessed from the external. So first to point the data, then the data only get the data to the controller for performing its operation. When you are connecting it to the external memory. Okay, external memory connect ചെയ്യുന്ന സമയത്ത് നമുക്ക് ഡാറ്റ ആക്സസ് ചെയ്യണമെങ്കിൽ external memory എന്നുള്ള ഡാറ്റ ആക്സസ് ചെയ്യണമെങ്കിൽ you have to use this data pointer. Okay, so that is what the data pointer. Here in 8051 IC, it is having 16-bit data pointer. 16-bit program counter is there for pointing the program memory. That means for pointing the instruction that next instruction that is to be executed. Okay, that means it will hold the address of the next instruction. Here it will hold the address of an external memory data. Okay, external data memory. Okay, and also it is having an 8-bit stack pointer. Stack pointer, you know that it is used to point the top of the stack element. Okay, whenever procedure call or something is performing, it will mainly use to point the it will use to point the top of the stack. So these are the important features of this 8051 IC. Oh, these are the features. 4 KB on ROM memory is there, that we will call it as program memory. Then 128-bit on-chip RAM memory is there, 8-bit data bus is there, 16-bit address bus is there, 32-bit general purpose register. Each register is having the size 8-bit, and 16-bit, two 16-bit timer, we will call it as T0 and T1. We can see what is timer and what are the user, timer or counter. Okay. Then 5 interrupt signals are the 3 internal interrupts and 2 external interrupts, and 4 IO ports are the each port is having the size 8-bit. Port 0, port 1, port 2, port 3. Sometimes we will call it as P0, P1, P2, P3, like that. Okay, P0, P1, P2, P3. Okay, so total 4 ports are there. That means total 32 IO lines are there for performing these IO operations, and the 16-bit program counter and one 16-bit program counter and one 16-bit data pointer is available in 8051 IC, and also it is having 8-bit stack pointer. Okay, 8-bit stack pointer. So these are the features of this 8051 IC. Now we can see the block diagram of this microcontroller. Okay, block diagram. Okay, of this 8051 microcontroller. So these are the different blocks available in this IC. So this is a CPU. Okay, CPU will be there. That means our processor will be there. Okay, including processor. There is a oscillator circuit is there. Then bus controller is there. IO port is there. Serial port is there. Timer is there. RAM memory is there. ROM memory is there. Interrupt control unit is there. Okay, so these are the different blocks present this 8051 IC. Okay, we can see what are the functions. And all these blocks are connected to the internal bus. Okay, all these blocks are connected to the internal bus. Okay, so these are the blocks. So first one is CPU. CPU means our processor. What is CPU? You and all know that. What is CPU? It performs all the operations in the microcontroller. Whatever the operation, arithmetic and logical operation that it has to perform, all these operations will be performed in this central processing unit. Okay, all these operations will be performed in this central processing unit. Okay, then there is an interrupt controller is there. Okay, what is the duty of interrupt controller? To control the interrupts, external interrupts and internal interrupts. Okay, as we studied that, it is having interrupts are there. Okay, how many interrupts are there? Three internal interrupts and two external interrupts. So total five interrupts are there. So for controlling that, there is an interrupt controller. Okay, so that is interrupt controller is this oscillator circuit is used to generate the clock pulse. Okay, for performing this operation and for performing to provide the clock pulse. Okay, for performing its microcontroller operation, this oscillator circuit is there. Okay, then 4K ROM is there. As we studied that, what is 4K ROM? It is a read-only memory that may be EEPROM or ROM. Okay, depending upon the versions that may be changed. Okay, it is having 4K bytes of ROMs are the internal ROMs are the for storing the program. Okay, for storing the program, it is having 4 kilobytes of ROM for storing program. Okay, then 128 byte of RAM memory is there for storing the data. Okay, for storing the data. So RAM is a data memory and ROM is a program memory. So ROM is read-only memory only. So that is why it is having one direction. Okay, so read-only memory. Then RAM, you can read the data from the RAM and also you can write the data to the RAM. Okay, so this 128 byte RAM memory is also available in this 8051 IC. Then timer and counters are there. Okay, two timers and counters are there. Timer 0 and timer 1. Okay, two timers and counters are there for performing timing and counting operations. Okay, for performing its timing and counting operations, we are using two timers. Okay, in programming and all, നമുക്ക് പഠിക്കാം എങ്ങനെ how we will generate the time delay and all for performing its operations. Okay, program for generating time delay and all and also counting operations and all we can counting purpose. Okay, counting the clock pulse, external events and all or internal timing operations and all we can use these timers. Both these timers we can use timer 0 and timer 1. Okay, so you can provide input, a counter input here and through timer 0 and timer 1. Okay, then this is the serial port. Okay, two serial pins are the TXD and RXD for providing serial communication. Okay, serial communication for inputting we can use RXD and for output TXD using. Okay, these are the serial port for providing serial communications. Detailed architecture ഞാൻ പഠിക്കുമ്പോൾ detailed ആയിട്ട് പറഞ്ഞുതരാം. ഇപ്പോൾ just ഓർത്ത് വെക്കാം. Serial port is used for providing serial communication. Two pins are associated with these serial communications are RXD pin and TXD pin. Okay, and as I said, the IO ports are the okay, 8051 is having IO ports. How many IO ports we have studied? Four IO ports are there. Okay, 8051 is having four IO ports are there. So we will represent it as port 0, port 1, port 2 and port 3. Okay, port 0, port 1, port 2 and port 3. So while programming and all, you can represent it the port 0, P0, okay, port 1, P1, port 2, and port 3. Okay, through these port, all these port, either you can transfer the data or address. Okay, we can see how these port will be communicated. Okay, so just it is having 4 IO ports are there. Each port having the size 4 bits. Okay, 4 bits. That means not 4 bit, 8 bit. Okay, 4 port, 8 bits. Total, how many? 32. Okay, P0 എന്ന് പറയുന്നത് 8-bit port ആണ്. P2 also 8-bit. P1 is also 8-bit and P3 is also 8-bit. Okay, total 4 ports are there for transferring address and data. Okay, എങ്ങനെയാണ് address send ചെയ്യുക, data send ചെയ്യുക എന്നുള്ളത് നമുക്ക് ഡീറ്റെയിൽ ആയിട്ട് പറയാം. Then to control all these bus operations and all. Okay, there is a bus control is there. Okay. So this is the block diagram of a simple block diagram of this 8051 IC. Okay, simple block diagram. One interrupt controller is the 4 KB ROM interrupt controller. It is having 2 interrupts, external interrupts and internal interrupts. Okay, then 4 KB kilobytes of RAW, 128 byte of RAM. ROM is for program memory. Okay, to store the insertions. RAM, it is used for store data memory, to store the data. Okay, and the timers are there for timing and counting operation. Serial for serial communication. Okay, for connecting the serial device like printers and all. Okay, for connecting that, you can use the serial port. IO ports are there for input-output communication. Okay, 4 IO ports are there. Each IO port is having 8-bit size. Okay, so P0, P1, P2, P3. Okay, then there is a bus controller is there to control all the bus transmission operation, and there is an oscillator circuit is there to provide the clock input to the processor or our chip to for working. Okay, to perform its operation. Okay, so these are the different blocks available in this 8051 microcontroller. Okay, so നമ്മളിപ്പോൾ എന്തെല്ലാം പഠിച്ചതെന്ന് ഇനി അടുത്ത പഠിക്കാനുള്ളത് ഡീറ്റെയിൽഡ് ആർക്കിടെക്ചർ ഓഫ് ദിസ് IC ആണ്. അത് നമുക്ക് വി കൻ സ്റ്റഡി ഇൻ ദ നെക്സ്റ്റ് ക്ലാസ്. ഓക്കെ, സോ we have studied what is a microcontroller. What is a microcontroller? It is a small, you can say that it's a small computer in an IC. Okay, that means it contain a CPU will be there, RAM will be there, ROM will be there, IO ports are there, timers and counters are there, serial port, interrupt, bus, everything within a single IC. We will call it as a microcontroller. Okay, a processor with all these components in a IC. Okay, is called the microcontroller. Okay, then these are the difference between microcontroller and the processor, and we have seen what are the different applications of microcontroller. And നമ്മൾ പിന്നെ പഠിച്ചത് 8051 microcontroller കുറിച്ചാണ്. It is designed by Intel. It's an 8-bit microcontroller. 40 pins are available, and different features നമ്മൾ നോക്കിയായിരുന്നു. 4 KB ROM, 128-bit byte RAM, 8-bit data bus, 16-bit address bus, 32-bit general purpose register, 2 timers, 5 interrupt, 4 IO ports, 1 program counter, 1 DPTR data pointer, and an 8-bit stack pointer. Okay. Then different blocks നമ്മൾ പഠിച്ചു അല്ലേ? Interrupt control, CPU, ROM, RAM, timer, serial port, IO port, bus controller, and oscillator circuit. Okay, doubt ഉണ്ടോ there? ഇല്ല എങ്കിൽ നമുക്ക് അറ്റൻഡൻസ് എടുക്കാം അല്ലേ? ആശിഷ്, അഭിനവ്, Abhishek, Aditya, Aishwarya, Akhil CV, Akhil K, Amal Surendran, Amina, Anaina, Anirudh, Anshita, Anuja, Anupama, Aromal, Arpit, Arundat, Ashwin, Fasna, Ramshada, Rutur, Jerish, Mithun,